Okay, so now we're going to go through how to write redox half equations. You need to know two things in order to write the half equation. The first thing you need to know is the charge on the ion. Possibly the most important. The second thing is the formula of the element. So usually the charge is fairly straightforward. You can get that from the periodic table. If it is group 1, then it'll be 1 plus. If it is group 2, 2 plus. Group 3, 3 plus. If it is group 7 or group 17, it will be 1 minus. If it is group 6, or group 16 if you prefer, it will be 2 minus, or even if it's group 5, it will be 3 minus, because it needs, so for example, nitrogen has the electron configuration 2.5, you add 3 electrons, it becomes 2.8, and it's the N3 minus ion, so the nitride ion is N3 minus. Now, so the charge usually comes from the periodic table. There is sort of one notable exception for the hydroxide ion. You need to know that is OH minus, but the half equation for that is something that you need to learn. Okay, 4 is the important number to remember for that one. Anyway, for the formula of the element. The formula of the element, if it is a metal, it is just the symbol. So calcium would be Ca, magnesium will be Mg. So if it's a metal or a giant compound, so giant metallic or giant covalent, but there won't be any giant covalent non-metals in the redox topic. Okay, so if it's a metal, even platinum, Pt, silver, Ag, it'll just be the metal. If it is a non-metal, the general rule is that it's a diatomic molecule. So chlorine, so if we just copy the periodic table, nitrogen is N2, oxygen is O2, fluorine is F2, we've also got Cl2, Br2, I2. Those are pretty much the only elements that you need. Okay, so how to write these things? First of all, for example, the oxidation of, so first of all, oil rig. Oxidation is loss, reduction is gain of electrons. Reduction is gain of electrons. Okay, so for example, let's go through the examples here. Complete the half equation for the oxidation of chloride ions to chlorine. So chloride ions are Cl minus, forming chlorine will be Cl2. It's a diatomic molecule. Now we have 2 atoms here in this molecule, so we're going to need 2 ions here. So we're going to have 2 Cl minus goes to Cl2. Now, what's actually happening here? We've got Cl, and Cl minus has 1, 2, 3, 4, 5, 6, 7 electrons to itself, and it also has this extra one, and we've got 2 of those. And when it forms chlorine, the dot and cross diagram will look like this. And we will have the 2 leftover electrons. So Cl, Cl. Here we have our covalent bond. So that is the covalent bond. That is our shared pair of electrons, and that is how the covalent bond is represented, just as the sort of stick diagram. Okay, so we've got 2 electrons which are cast off, so we're going to have plus 2e minus. So 2Cl minus goes to Cl2 plus 2e minus. So if we put that in, 2Cl minus goes to Cl2 plus 2e minus. Okay, now the next one is copper. So we've got copper, and copper is one of those ions that you do need to learn. So you've got Cu2 plus, and the formula will just be Cu because it's a metal, it's a giant structure. So we're going to have plus 2e minus goes to Cu. Very easy. Copper is 2 plus. It needs 2 electrons to make it neutral to form copper. Okay, so that is done. Let's just put that in. It's just Cu, whoops, and charge is 2 plus. We're going to need 2 electrons, and it's just going to form Cu. Okay, now the next one, nitride. So the nitride ion is N3 minus, and it's going to form nitrogen, which is a diatomic molecule, N2. This one's a little bit interesting. It's got a triple bond between it. Because nitrogen is 2.5, it has up, down, left, right, up. It has 3 unpaired electrons. So it has 3 unpaired electrons, so it can form 3 covalent bonds. So an N2 molecule has this NN triple bond in the middle. We've got our diatomic molecule here. It has 2 atoms here. How many ions do we need? We're going to need 2. So this is 2N3 minus. So these 2 nitrogen ions have a total of 6 electrons. Okay, so we're going to fill that in. 2N3 minus goes to N2 plus 6 electrons. Okay, complete the half equation for the oxidation of iodide ions to iodine. So iodide ions are I minus. It is group 7 or 17 if you prefer wrongly. So I minus, it has a single extra electron, and iodine exists as I2. So we're going to need 2 of those because it's a diatomic molecule. We're going to need 2. So you can think of this as having 2 nuclei. We're going to need 2 nuclei here, so we're going to need 2 lots of the iodide ion. And then because we've got 2 of the iodide ion, it's 1 minus, it's going to lose 2 electrons. So this is oxidation because it is losing electrons. So the half equation for the oxidation of iodide ions to iodine, that will be it. So we've got 2 I minus goes to I2 plus 2 electrons. Okay, and the final question, complete the half equation for the reduction of nickel ions to nickel. So nickel ions are Ni2 plus, helpfully gives us that in the question, and nickel is a metal, so it is just represented as Ni because it has a giant structure. So it's got a 2 plus charge. It's going to need 2 electrons to become neutral. So that's it. Very straightforward. N2 plus. So here we have, oh, we don't need the number, just nickel 2 plus 2 electrons goes to Ni. And let's just click submit, and hopefully everything is correct. Fantastic. Okay, hopefully these questions are quite straightforward now.